morning and happy Friday. I want to welcome you to the final day of 2024 AIAA Aviation Forum, and I sincerely hope that you have enjoyed this week as much as I have. I'm John Kowalowski with NASA, and I'm honored to serve on the Aviation Guiding Coalition. It's been great to see so many members of our community convening this week at what has been mentioned a couple times here, and I think appropriately so, as the Aviation Olympics. And I'd like to think that as you've spent your week with us and have shared in so many of these technical sessions and these plenaries and these 360s, that you feel the exact same way. Outstanding work that's been presented. But I also want to take a moment here to ask you to please join me in thanking so many people and organizations who have made the 2024 AIAA Aviation Forum such a success. So thank you to our premier sponsor, Lockheed Martin, our top sponsors, the Boeing Company, Northrop Grumman, the Aerospace Corporation, ULA, RTX, and Aerojet Rocketdyne. I also want to thank our incredible guiding coalition and our technical program committees, without whom so much of the content and the tremendous value that you get out of this forum wouldn't happen without. They've just been tremendously supportive of this forum and AIAA overall, so many thanks again, in particular the technical program committee members. There are hundreds of AIAA volunteer members as well, and certainly the very impressive technical paper presenters that are all part of this. There are also a few organizations and individuals that work behind the scenes to ensure that you have safe, comfortable, and enjoyable experience at the Aviation Forum. So please join us in thanking Lumens, our audiovisual provider, Arata, the exposition services who make everything look so good, and of course the AIAA staff and all the folks behind the curtain here that make the magic happen. You've worked tirelessly to ensure that our community would benefit from the Aviation Forum yet again this year. So thank you all. On our final morning, let's begin by recognizing the winners of the student paper competitions. I'd like to ask Leslie White to join me here on stage from the AIAA Technical Activities. She's the Technical Activities Chief, Division Chief, and she'll be joining me to help make the award presentations. These undergraduate and master's level students have submitted and presented their papers through the regular technical review process, just like all of us, with many more years of experience. Their work is incredibly impressive, and I'm pleased to present the following awards. So our first student paper competition is the AIAA Air Transportation Systems Award. The Best Student Award in Air Transportation System recognizes the best student paper each year in the Air Transportation Systems technical discipline at AIAA Aviation. First place winner of the 2024 AIAA Best Student Paper Award in Air Transportation Systems goes to the paper Amelia, a large model and data set for airport surface movement forecasting from Carnegie Mellon University students I. Navarro, P. Ortega-Kral, J. Petrarca, H. Wang, Z. Ye, J. H. Park, J. O., and S. Scherer. And the runner-up paper, thank you. And the runner-up papers analyze potential of dynamic aircraft wake separation via data-driven aircraft wake region detection from Hong Kong Polytechnic University students, N. Chu, K.H. Yang, Y.U., and K.K. Han. Congratulations to all. Okay. And folks, to all, I want to apologize up front. I'm doing my best with the names here, and I apologize to everyone that I may be butchering their names, but do honors and support to all of you, so thank you. Our next competition is the AIAA Best Paper Award in Applied Aerodynamics. The AIAA Applied Aerodynamics Technical Committee is sponsoring the APA student paper competition. Final papers will be judged based on the importance of the work, originality, quality, and completeness. And the winner of the 2024 AIAA Best Student Paper Award in Applied Aerodynamics is Harsha Sista, Iowa State University, with the winning paper, Experimental Study on Detrimental Effects of Rainfall on Wind Turbine Blades. Congratulations, Harsha. Our next student paper competition is the AIAA Best Student Paper Award in Atmospheric and Space Environments. The AIAA Atmospheric and Space Environments Technical Committee sponsors this competition. The written papers will be judged based on the following criteria: originality, technical quality, organization, completeness, grammar, and usage, literature review, acknowledgement of prior work, and explanation of the relevance of the work presented in the paper, accuracy of experimental or numerical results, and the importance and contribution to the field. The winner of the AIAA 2024 Best Student Paper Award in Atmospheric and Space Environments is Thomas Cross from the University of Oxford. A finite element-based fracture model for the prediction of shedding in ice crystal icing. Congratulations. Our next student competition is the AIAA Computational Fluid Dynamics Student Paper Competition. The 12th AIAA Computational Fluid Dynamics Student Paper Competition provides students the opportunity to share their research findings. Awards are based on a combination of the extended abstract, the final conference paper, the presentation, with specific criteria on the work's importance in advancing the state of the art, the technical approach, the rationale for the work, sufficient and consistent results, verification and validation, style, clarity, and format of the paper and presentation. First place goes to Manuel Viguera Moreira from the University of Maryland with his winning paper, Implementation and Validation of a 7-Equation Model for High-Speed Droplet Impingement. And the second place goes to Nicole F. Nutter, University of Tennessee, with her winning paper, Thermochemical Non-Equilibrium Modeling in a Continuous Galerkin Finite Element Framework. Congratulations. Actually, and there's a third place. It goes to Vaishnavi Ramaswamy from the Massachusetts Institute of Technology, and with his winning paper, Ultraspherical Polynomial Spectrum Method for Boundary Layer Stability Problems. Unfortunately, Vaishnavi is unable to attend, but we send him our sincere congratulations. Our next student paper competition is the AIAA Intelligent Systems Student Paper Competition. The AIAA Intelligent Systems Technical Committee sponsors this competition, and the committee will review the extended abstracts based on their originality, clarity, and potential impact on practical applications or theoretical foundations. The 2024 Intelligent Systems Student Paper Competition winner is Cynthia Koopman, University of Malta. With her paper, Towards Safe Aircraft Control with AI, Reinforcement Learning with Guardian Angels and Mischievous Gremlins. Congratulations, Cynthia. Our next student paper competition is the AIAA Multidisciplinary Design Optimization Student Paper Competition. This competition is sponsored by the NASA Glenn Research Center, encourages undergraduates and graduate students to submit papers to the technical topics listed in this call for papers. The award decision is based both on the paper and the presentation. Judging criteria are the originality and technical quality of the work and its novelty and importance to the field, the clarity of the presentation with special emphasis given to visuals and their contributions to the understanding of the material, and the clarity of the research objectives in the organization and conciseness of the paper. First place winner is Jasper Boosmaken, German Aerospace Center, DLR. And his winning paper title is Surrogate-Based Optimization of System Architecture Subject to Hidden Constraints. And the runner-up is Jean Wei, École Polytechnique Fédérale de Lausanne, or EPFL, with the winning paper Deep Geometric Mapping for Automated and Effective parameterization and aerodynamic shape optimization. Congratulations. Okay. Our final student paper competition is the 2024 AIAA Best Student Paper Award in Uncrewed and Autonomous Systems. The Uncrewed and Autonomous Systems Integration and Outreach Committee sponsors this competition. Winning paper is evaluated on technical discipline selection criteria, specifically scope and significance of the contribution and originality, impact on the domain of unmanned systems, relevance in system optimization, integration, simulation, flight testing, and implementation of technologies for the advancement of unmanned systems domain. The winner of the 2024 Best Student Paper Award in Uncrewed and Autonomous Systems is Keldon J. Ben-Ora, University of California, Davis, for the design and flight of an autonomous Regalo glider and recovery of high-altitude balloon payloads and data. Unfortunately, Keldon is also unable to attend, but we do again send them our hearty congratulations. So thank you to all the technical committees supporting these competitions, and especially congratulations to the student winners. Congratulations to all. Thank you so much. Good. So I want to begin this morning's session again with our plenary speaker that's going to be helping us bring it all together, again, from vision to velocity. As the industry pursues a sustainable and high-tech future, the forum has touched on so many of these key topics driving the industry, such as sustainability, automation and AI, increased capability, and advanced air mobility. So I'd like you please to welcome us and welcome to the stage as we hear more from our plenary speaker, Jim Free, the Associate Administrator of NASA, who will have a fireside chat with AIAA CEO, Dan Dumbacher.
Well, good morning, good morning. Thank you, John, for the introduction. Thanks to AIAA for having me here today. Thanks to all of you for being here. I was kind of thinking Friday morning, last day, Las Vegas. We'll let your imagination go from there. First thing I'd like to do is thank Catherine Hamilton. Catherine is one of our comms specialists for all the work that she did to help put this together with her colleagues from our Aeronautics Research Mission Directorate. I hope you have all had the opportunity this week to really make some great connections. That's what I love about these. Just walking the hall this morning, I kind of took back to myself to these days, certainly with Ascend and the Aviation Forum here. It's a great opportunity. And today's theme, as John talked about, of bringing it all together, is what I'd like to talk to you about from our 50,000-foot view and where I get the privilege of seeing it from NASA, how we're trying to shift the paradigm going forward with our work, confront all of the global challenges that we face, and looking over the horizon to bring it all together from NASA's perspective. So our 50,000-foot view starts with our mission statement, where we explore the unknown in air and space, we innovate for the benefit of humanity, and we inspire the world through discovery. I think you'll hear a lot of talk recently about our whys, and I encourage you to go see our whys online that go deeper into our mission statement, our whys of science and national posture and inspiration. The core of what we do in aeronautics at NASA is to advance aviation for public good in three specific ways. Safety is our top core value and our top priority for aviation. Beyond safety, we look at pushing innovation. And the third area is focusing on improving lives here on Earth. And NASA is working to make aviation safer, faster, and cleaner. We, represented by all of you in this room and those that attended both conferences this week, are really about that going through that process of shifting the paradigm, confronting those challenges, bringing the horizon closer, and this is really NASA's role. We're leading the transformation of aviation in four technical areas that you see here. Ultra-efficient airliners. We're accelerating the ability of the next generation of large commercial aircraft to use less energy and be cleaner as well. Our work is a major contribution to the U.S. goal of net zero greenhouse gas emissions by 2050. High-speed commercial flight. We're removing a key barrier to commercial supersonic flight over land by proving that we can reduce the sonic boom. We're doing that with our federal partners, critical partners like the FAA that span interfaces in our entire agency. Advanced air mobility. With nearly 100 industry partners, we're working to enable an economically viable and safe system in which aircraft from drones to air taxis can fly new missions over the most rural countryside to the most dense urban areas. Our advanced air mobility mission is working with the aviation community to solve the challenges in vehicle development and operation, airspace design, and community integration. Future airspace and safety. We are, frankly, leading the world in this area. We NASA, we the U.S. We're working with our FAA partner to continue evolution of our national aerospace system, to safely integrate all types of air vehicles in an increasingly complex environment, and to do so more sustainably, using digital technologies on the ground and on board the vehicles to enable more efficient trajectories that use less energy. Our primary contributing role and largest investment is in R&D of technologies, and I hope you've heard a lot about that this week, from low emissions to low noise aircraft. I'm hoping you've had a chance to attend those related sessions during your time at this year's conference. If not, take the program, reach out to our researchers. There's nobody that is more willing to talk than our incredible research community at NASA. I would say cleaner air travel through ultra-efficient airliners is a prime example of how NASA is confronting global challenges from a civil aviation perspective, and that does require the paradigm shift I talked about earlier. We're developing and testing green technologies for next-generation aircraft by developing new digital tools for greener flight operations and by identifying the challenges and benefits of sustainable energy options for aircraft propulsion. We're partnering with industry, academia, and other agencies through the Sustainable Flight National Partnership. The partnership is researching and demonstrating high-risk, high-payoff technology advancements. That's what we do at NASA. Fuel consumption reduction, up to 30%. You all know that buying back 0.1% today is important, let alone 30%. We want to have the capacity to use 100% sustainable aviation fuel and reduce the non-CO2 impacts from aviation. The X-66 Sustainable Flight Demonstrator. I love this. This is the most adjectival qualified aircraft I've ever had. I'm going to read these to you. First ever, large-scale, ultra-efficient, transonic, truss-braced wing, subsonic flight demonstrator aircraft. I was practicing that, and for a space guy, that took a lot. It integrates green technologies to enable 5 to 10% reduced fuel burn. There we are again, right? Think about the savings, not just from a emissions perspective, but from an economic perspective of 5 to 10% reduced fuel burn. We're also working with companies like GE Aerospace and Magnix to advance green technologies for electrified propulsion that will reduce that fuel burn and emissions in the very near future. The Electrified Powertrain Flight Demonstration Project conducts ground and flight tests of electrified aircraft propulsion technologies to enable a new generation of hybrid electric-powered aircraft. Two other tech demos that we have are HiCam and HiTech. HiCam is a high-rate composite aircraft manufacturing demonstration that develops processes to achieve the manufacturing of large-scale wing and fuselage composite components 4 to 6 times faster, with an ultimate savings of 5 to 8% in fuel reduction. HiTech is hybrid thermally efficient core, where we'll demonstrate the first ever hybrid electric jet engine core that is more compact and that can provide equivalent power, but with 5 to 10% reduced fuel use. Beyond the tech demos at NASA, in partnership with the FAA, airlines, and airports that I'll talk about more in a moment, we're implementing several multi-year flight operation demonstrations as well. High-speed flight has been and will continue to be a game changer. Some of us, and this probably shows my age, remember the Concorde and supersonic flight over water, but supersonic flight over land has been banned since 1973. And I hope you've heard, we're working towards the audacious goal to prove we can fly supersonic flights over land while mitigating sonic booms to mere thumps. NASA's working with industry to enable new choices for high-speed air travel, starting with commercial supersonic flight over land through the Quest mission and the experimental X-59 aircraft. And that picture is, the artist rendering here is incredible, but to stand next to that aircraft was really transformational for me to see where we're headed with aircraft development. Our Quest mission is to collect data to present regulators that may lift the ban, making commercial supersonic flight over land a reality again. X-59 is designed to fly faster than the speed of sound with producing only sonic thumps. And if that wasn't fast enough, we're studying hypersonics too. And from a space perspective, we'll talk crossover here in a minute. We fly hypersonic when we leave the atmosphere and when we come back in our spacecraft. We also want to push that on the aeronautics side. Looking at vehicles traveling faster than 5 times the speed of sound, ultra-fast flight through hypersonic technology is not impossible. We're conducting fundamental and applied research to enable a broad spectrum of hypersonic systems and missions. In the coming decade, think of that, in the coming decade, we envision the development of technologies for a first-generation reusable air-breathing vehicle using oxygen in the atmosphere and capable of cruising at hypersonic speeds. In the long term, we envision reusable hypersonic vehicles with efficient engines for routine access around the globe. A little bit closer to home, our work in advanced air mobility will revolutionize urban and regional mobility, economic growth, and opportunity. NASA has been and will continue to be a fundamental enabler for this new market, especially in the area of airspace integration and the use of autonomy. We know industry is building new types of low-altitude aircraft, and they want to get these certified by the FAA. We're delivering data to guide the industry's development of these electric air taxis and drones and assisting the FAA in safely integrating these vehicles into the national airspace. And NASA's answering questions like, what are the design requirements for safe and quiet vehicles? What are the pilot training qualifications for these aircraft? What infrastructure would an airport need to include to support these aircraft? We aim to help to springboard the industry. Springboard the industry is what NASA Aeronautics has done since its inception, and enable that successful domestic industry business models and ensure the U.S. has global leadership in the advanced air mobility market. And when disaster strikes, help could be on the way in the future with new aircraft assisting firefighters on delivering supplies and relief in hard-to-reach areas. In another project contributing to the advanced air mobility mission, NASA is tackling the challenge of how to achieve substantially improved wildfire outcomes by engaging key wildfire management communities to test a NASA-developed system. We announced in April that NASA and the FAA have established a research transition team to guide the development of wildland fire technology. Wildland fires are occurring more frequently and on a larger scale than in past decades, according to the U.S. Forest Service. Emergency responders will need a broader set of technologies to prevent, monitor, and fight these growing fires. Drones could overcome this limitation and enable responders to remotely monitor and possibly suppress these fires during nighttime and low visibility conditions. The biggest benefit is they can fight them 24 hours a day. Today, they're limited, as I said, by line of sight. However, advanced aerospace management technologies are needed to enable these vehicles to stay safely separated and allow aircraft operations to maintain situational awareness during the wildland fire management response operations. As part of our future airspace and safety transformation area, this research transition team with NASA and the FAA will develop concepts and test new technology to improve that airspace integration. The team will conduct a series of demonstrations in relevant environments to pave the way for integrating them into future wildland fire operations. Whether it's drones that will one day help fight wildfires or large airliner carrying you or cargo, Our ongoing work to advance airspace and safety are foundational elements to the future of aviation. From sustainability to traditional airline operations and advanced air mobility to high-speed flight. Today, every U.S. commercial aircraft and air traffic control tower uses NASA-developed technology that improves both efficiency and safety. Our decades-long partnership with the FAA continues as we build on the efficiency gains, leveraging digital capabilities on the road to an airspace that is safe, adaptable, scalable, and now as a primary goal for NASA, sustainable. For example, ongoing in North Texas multi-center area, our test of pre-departure rerouting tools for FAA and airline controllers that provide more real-time departure options that not only reduce delays, but are proven already to save thousands of pounds of fuel and carbon just in that one sector. I talked about our mission statement and us fostering innovation. We foster innovations in physics-based tools, novel technology, and advanced systems concepts that support the future of the entire aerospace industry. This innovation ecosystem attracts and cultivates the energy and ideas of people inside and outside NASA who ask, what if and what's next? Innovation is a central theme for all of our work in aeronautics. We have 3 specific projects within our Transformative Aeronautics Concepts program that are dedicated to fostering innovation from within NASA as well as from outside the agency. The Convergent Aeronautics Solutions Project aims to foster a culture of innovation by advancing disruptive system-level concepts and early-stage technology for transformational impacts. Our University Innovation Project supports educating the next generation of aeronautical innovators, some of which you saw on the stage here, by providing opportunities for university-led teams or individuals to conduct research in transformative technology. The Transformational Tools and Technologies Project develops state-of-the-art computational and experimental tools and technologies that are vital to ARMD's ability to advance the prediction of future aircraft performance in flight, like AVIATION, a new software platform available through GitHub that enables design of future aircraft with non-traditional propulsion or aerodynamics characteristics. Our GX810, a 3D printable high-temperature material for more durable airplane and spacecraft parts, was recently licensed to 4 companies in the U.S. and frankly is already being used in a rocket engine, which is pretty cool. In addition to the innovation ecosystem, our Aerosciences Evaluation and Test Capabilities portfolio enables rapid experimentation and feasibility demonstration of advanced air vehicles and concepts from government and industry, from subsonic to hypersonic speed, through wind tunnels and other test facilities. We're transforming ground test capabilities with new technology to improve test performance and value. And these state-of-the-art facilities are not only taking NASA into the future of aviation, but supporting missions to further understand the solar system and to expand human presence farther into space with our Artemis campaign. Now, as someone who spent most of my career on the space side, I couldn't come up here and not talk about space, but it's not just because I spent my time in space. It's because we have examples that bring it all together across projects that we use in both aeronautics and space exploration. From an engineering perspective, we use some of the same facilities and tools, and we benefit from the same areas of expertise that you heard about thus far today, and I'm sure this week. But when combining our minds together, combining the best of aeronautics and space, we come up with some of these groundbreaking changes. First, a Dream Chaser, all the way on the left. This is Sierra Space's uncrewed space plane, and it's part of our efforts to expand commercial resupply in low Earth orbit to the International Space Station. Right now, we only have one method to get cargo back from space station, the SpaceX Dragon. Dream Chaser will give us that second option. Dream Chaser is rooted in NASA's aeronautics development. It's a lifting body design that measures 30 feet by 15 feet. The unique wing design allows it to land on a runway much like the space shuttle did. Then there's Ingenuity. I'm not going to do Ingenuity justice. By the way, we flew on another world. I think I could just leave it there, but I'll say a little bit more. It was a tech demonstration, powered and controlled on another world. A 4-pound helicopter completed 72 flights over nearly 3 years, exceeding expectations in every dimension: time, distance, and altitude, all on aeronautics foundation. And then there's Dragonfly, what's in the future. It's a rotorcraft mission to explore the biggest of Saturn's 62 known moons, Titan. It will take advantage of Titan's dense atmosphere and low gravity, flying to multiple locations to sample and measure the composition of organic surface materials. It'll be about the size of the Mars rover, about 12 feet, with 8 rotors and octocopter lander. Truly will be incredible to watch what comes back from that. Again, despite the fact that all 3 of these are leaving Earth's atmosphere, they're applying aeronautics knowledge and expertise to explore the unknown in air and space for the benefit of humanity. So getting back to the themes of the week, all of these projects are on our horizon, near term and far term. And some of those near-term ones are closer than you think. And bringing it all together, NASA is working to enable industry to introduce transformative options for future air travel and maybe even a bit farther. We started with the mission statement at our 50,000-foot view to make sure we understand why our work matters. Then we take that 50,000-foot view and identify partners who are ready to challenge the paradigm, confront the challenges, and imagine the future so that we can make it a reality together. For more than a century, NASA has been the global leader in aviation research, and we're planning to lead for that next century as well under the leadership of Bob Pierce and Carol, and frankly, all the wonderful people that work at NASA. The knowledge and technology breakthroughs from our work are transferred to other agencies and industry for the greater benefit of all. So whenever I give a talk, I can't leave without giving you an action. Now, you're at the end of the week. Sometimes I get to speak at the beginning of the week. So end of the week action. I want you to leave with a thought of how can you be part of bringing it all together? How can you reach across to another discipline, to another vehicle, to say, how do we work together? Do we have the right workforce? Do we have the right partner? Do we have the right perspective? NASA also needs your help to bring it all together. We've got some tough challenges, some bold goals, and we need the best from government, academia, and industry. So with this bright future ahead, and built on the pieces that we talked today, I look forward to see where the future of aviation takes us next. Thank you very much for being here, and now the best part of it, I get a chance to hear questions from all of you.
Thank you, Jim.
Which side do you want me on?
Thank you, sir.
Thank you.
Great. I particularly want to thank Jim for making a special trip out here to be with us at Aviation. He was kind enough to fly from Boston and the Space Station Research and Development Conference this week to join us here. So thank you for making this.
Thanks for the opportunity, Dan. What I do have to say is I did stop in Houston on the way. Can't fly cross country without stopping in Houston.
That's the center of all NASA activity,
it is,
right?
Yes.
Don't tell JSC I said that. Or don't tell my friends at Marshall I said that. Great presentation. Thank you very much for all of that. A couple of questions, and we've got some questions rolling in from the audience. Please send your questions in via the app, and we'll be ready to go. I'm going to pick up on your last couple of comments. How do you continue to see the overlap and the synergies between the space side and the aeronautics side and how that seems to be evolving? That's been a little bit of a conversation this week, given Ascend and Aviation are co-located. Just wanted to get any additional thoughts you might want to add to that.
Yeah, I think I talked a little bit about it. I'll go to tools. I kind of leave facilities aside. I think facilities are an obvious connection, but tools. Aeronautics funds and maintains a great deal of the tools that we use. As I said, we fly through the atmosphere going to space and coming back, so some of those fundamental tools are the same. I think there's tech development. I talked about GRX 810. That is an incredible material that has great potential in aeronautics and is being applied in space and being licensed by 4 different technologies. So I think it's continuing to maintain a little bit of that last theme that I talked about, even within NASA, to get rid of the stovepipes between space and aeronautics and think outside of the lines we normally think in. Your incredible career that you had at the agency, your service to this country in doing that, you saw how those, I've heard the term stovepipes of excellence are out there. They can develop, but sometimes you have to find that way to reach across and imagine things a little bit differently. So there's a creative thought process got to go with it and make it happen.
Good, thank you. The top voted question already for this is, can you speak to the importance of the aeronautics research at NASA, given all the space operations activities and all the work over there?
I thought the top question would be, what's your favorite Dan Dumbacher story? But we'll come back to that.
Nobody wants to know that.
We'll come back to that. Yeah, so the first A in NASA is aeronautics. I think everybody's probably heard that multiple times. I would not judge the budget difference as a relative importance. The aeronautics budget has grown over years, and frankly has the best payback to industry, I think, by enabling the commercial aviation industry. So I don't look at it as, hey, we're comparing one to the other. They're different. They're different in what they do. Space operations, science mission director at Space Technology, they have a more, I'll say, timeline, project-driven model. Aeronautics has the project-driven model, but it's also driven by the needs of industry, which there's a lot to learn of how Bob Pierce and aeronautics manages that we can learn on the space side. I don't think there's ever going to be an equity if you're looking for a one-for-one. I don't think it's going to be there. But the budget that Aero has, I think, is applied very wisely. The 4 programs I talked about, how they're run, how they take technology down here and move it into reality.
Good, thank you. I want to pull that thread a little bit further, the budget thread. What just standing back and looking at it, and I know from firsthand experience I suspect what's going on. What do you see, what's your perspective on the budget for NASA, particularly the Aeronautics Mission Directorate, as you look at 25 and beyond?
So 24 and 25 were challenging years with the, I always get it wrong, Fiscal Responsibility Act. I see Bob Gibbs out there. If I'm saying it wrong, you can throw something at me. Or we had, across the government, right, we had to cap our budget. That put a toll on all of our missions. I see the future as we look. We're developing our fiscal year 26 budget right now. I look at great possibilities that aeronautics has brought forward. If we want to continue to lead across all of what NASA does, we need to invest. And there's economic pressures that drive that. We have inflation that's driving it. Everybody's losing buying power because of things like inflation. But we need to justify the outcomes. I shared with you some of the aeronautics outcomes that are there, benefiting commercial industry, driving down cost, increasing our own personal travel, bringing jobs. We need to present that, and our funders in Congress need to support that if they see that as the greatest need of the country. I certainly see it as that. But if we're going to continue to lead, we need the funding to do it.
Okay, this is an interesting question that crosses back to crossing the 2 domains. How do you see the commercialization of space changing and influencing the research and technology development? And is there something there to be learned from what Aeronautics Mission Directorate has been doing for so long? As you mentioned, it's been driven by industry needs. Is there a corollary there from a space side?
I think 100% there is. Robert Lightfoot, who used to have this job, always talked about how aeronautics was 50 years ahead of space in commercialization, and hopefully we're heading in that direction by seeding the development of technology, joint funding projects. You heard me talk about the X-59 and X-66. Those are joint funded projects, joint funded research. We're trying to use those models on the commercial space side where we've done it on commercial cargo and commercial crew to space station, trying to seed the market. I think aeronautics did that years ago, and continuing, aeronautics has a great model of listening to industry, the needs of industry. We're trying to do that on the commercial side. We just had our shortfalls in the Space Technology Mission Directorate that have some aeronautics crossover. But so trying to listen to industry, get feedback, what are the needs, so that then we can prioritize our funding, much like aeronautics has done.
Good, thank you. You started something, and guess what is now the most voted question? And no, you're not going to answer it right now.
My best Dan Dumbacher story?
No, we're not going there just yet.
Okay.
Only if there's time.
We only have 18 minutes left, though.
Yeah, later. Later, man. How is making supersonic commercial flights compatible with net zero in 2050, and what's NASA doing to help make that happen?
So I think they're obviously interrelated. We first have to overcome the ability to go to the sonic thump. And then I think we have to look at our engine development and getting to that net zero. So it's an incrementally oriented program, and we've tackled the X-59 first and that sonic thump, and then we need to continue looking at how to drive down the emissions. But it's not lost on us that the two are related, and Bob Pierce and the team, they have a plan to address that.
So there is a question here about how is NASA going to get the data from the sonic thumps and what from X-59, how is that going to be dispersed, and what do you see as X-59's legacy in the long line of X vehicles?
First, it's great to have an X vehicle back. We're certainly learning what it's like to have a X vehicle go through the process with our partner great partner we have in Lockheed Martin in that co-development. We have multi-phases, so obviously the early phases are, let's first get the aircraft flying, let's fly it over Edwards, start taking some data there. And then in the phase 3 and 4, we'll go around to fly across the country and have a way to engage with the communities to get the feedback. We're going to fly over this time these days. What's the feedback? We did some of that early testing with microphone arrays a number of years ago, where we're looking at getting feedback from communities. So it'll be that feedback, and much like all of our science, all of our data, we are completely open with that across our programs, and Science Mission Directorate as well. We'll share that data of what we get back on our open platforms.
Good. Achieving sustainable flight's a worldwide challenge, and NASA's obviously putting a lot of effort into it. How do you think how can NASA work with the global partners around the world on that important initiative of sustainable flight?
Yeah, I think it's about how do we. We have a lot of international relationships on the space side, International Space Station, obviously that's in the name, but what is lost is that our aeronautics team work with their counterparts across the world in corresponding organizations in other countries with international certification bodies on I'd say more than regular basis to lay out our plans and then merge them together where it makes sense, or take learning from another agency to fold into our plans. And I don't know all of them off the top of my head, but I do know there's significant interfaces with our European counterparts, with our Japanese counterparts as well.
Good, good. And AIAA works with ICAS and others to help that kind of thing happen, so more than happy to go there. Similar question, but from a U.S. national agency perspective. Blended wing body, hypersonics, those kinds of things. How is NASA working with DoD? Ravi Chowdhury was just here the other day talking about blended wing body and the need from an Air Force perspective for sustainability and reducing the logistics train How is NASA participating?
Yeah, much like across all of our disciplines, we share technology where it makes sense to share technology. So we, number one, are responsible with the taxpayer dollars so that we're spending dollars wisely, we're not duplicating. And number two, other advancements by other organizations we can take on, we'll also share. We'll do, in some cases, co-development with partners in the Air Force, in the FAA. I talked about here. Obviously, that's part of the whole picture of sustainable flight. Is not just how you build the aircraft, but also how you operate it as well.
Good. There is the question. I guess we both kind of suspected this was going to come. What do you see as what's the status of Starliner right now?
Isn't this an aviation conference?
It is.
Okay. I guess I brought
but
together
we have curious
space and
minds
aeronautics.
out here that would like to know.
We continue, thank you for the question. First of all, let me say openly, there's probably nothing I want to say more than the crew is not stranded on space station. This is a test flight. Test flights, you learn about the vehicle. We much like every aircraft you fly, you have a test flight, you learn about the vehicle. We learned a lot about this vehicle, about how it operates in incredible ways. We're also learning about some of the challenges. We've talked about the helium leaks that we've had. We talked about the thruster issues that we've had. We completed a number of tests at White Sands a week ago tomorrow, so last Saturday. Took apart the thruster. We're learning a lot about the inside of that thruster. We certainly understand. We ran 5 sets of tests. I'm modeling trying to recreate what we saw going to station and trying to model and show what we expect on the downhill side of things. And we're hoping to make some decisions. We met a couple times this week, hoping to make some decisions here in the next couple weeks of our path forward. Butch and Sonny are certainly having 80 hours extra a week of help on space station. It's been tremendous. If you're an astronaut, the best place you want to be is in space, so they're certainly happy. They're brought into every discussion that we have technically. A lot of times they're listening from the ISS. And we're going to make the decision that keeps them the safest, but also realizing that this is a test flight, and in some cases you're pushing the boundaries. But I want to make sure you're not stranded. We learned a lot of good things about this vehicle, and Boeing, our Starliner partner. We need to understand that we can bring them home safely, and that's what our goal was before we launched, and it's our continued goal now.
And thank you for that. We need to keep reminding ourselves that this is a test flight.
Yes.
And there's always funnies that show up that have to be addressed. How do you see NASA growing its workforce for the aeronautics, particularly aeronautics for this community, but also even space?
Yeah, I think we have a challenge across, and I would say in industry, to make sure that, number one, we're inspiring people to take on this role. To me, the inspiration comes from the missions we fly. I'm not just talking space missions, I'm talking aeronautics. I hope that some young child, when X-59 lands at their aircraft, or at their airport, watches that aircraft land and says, man, I would love to go do that. I think we're the best education investment there is in NASA. So we have to fly the missions to inspire people. We have to make sure we have the programs for that. The university initiative that aeronautics has is tremendous. It inspired a school to start an aero program. You're not gonna get better than that. And we need to have our science, technology, engineering, and math programs touch every age. To see those students up here, they were students years ago, and small students years ago, and they got inspired to be here. We need to keep inspiring it, and we have to have the workforce to do this, which means we also need the funding. So it's the funding to do the research, but the funding to keep our workforce as well.
So on that thought a little bit, what advice do you have? We have young professionals here, students, we have 24 diversity scholars, all women, a couple of veterans. What advice do you have from them based on your career experience that you would like to share with the younger community?
Boy, so I have two.
By the way, I did this to Scalise the other day too.
He called me yesterday too. I wonder if he was giving me a heads up. I missed his call. First of all, I'd say find a mentor. I only sit here today because I have had folks who've mentored me, and mentors are people that encourage you, but also challenge you and see things in you that you can't see in yourself. I say that I feel like every time I get this question, people will see things in you can't possibly see in yourself. And those mentors, one of which I mentioned, Robert Lightfoot, continue to do that for me today. And I have two aero engineers right now. One's a senior, one's going to be a senior, one's going to be a sophomore. And what I tell them every day is get hands-on experience. Hands-on running code, developing a code, hands-on working on hardware. I feel like in the jobs I've been fortunate enough to have, including this one, I can engage because I had some of that foundational experience. So that's what I would say.
Good, thank you. So I was hoping
we're going to get
have
there.
time for
we're
this.
going to get there, Dan.
You're making me get there.
We're going to get there.
Wildfire management, you talked about that a little bit, a task that's confronting all of us. Is NASA involved in the wildfire suppression and firefighting using either large aerial suppression systems, fire retardants, or both?
Well, so our involvement is kind of in the overall group and bringing our technology to it. We're not flying the missions to suppress the fire. We're bringing the technology to the integration group for them to bring it to bear on the problems. So my favorite Dan Dumbacher story. I'm just going to cut you off, Dan. Let's just go.
Well, that's the way this goes between the two of us. By the way, before you do that, sure. You will need to know that my wife will be more than happy to know that I was on stage today with her fellow Miami of Ohio graduate.
Go Redhawks. That's right.
That's
right. Yes. So I'll give you one funny one and then one serious one. And the funny one kind of spans a number of years. When you come to work, so maybe this goes to the advice, when you come to work, the only way I can get through it is by joking around and laughing, because the topics we deal with are pretty weighty, and in the human space flight side of stuff, it can be incredibly weighty. And you look for people, no matter what you're doing, people that you enjoy working with, people that don't take themselves too seriously, but bring incredible technical and/or programmatic depth. And Dan is one of those people. I think in all the times I would go by Dan's office when he was at headquarters, it was always, hey, we always started with, how you doing? How's your family? People that care about who you are as a human being. Dan's one of those folks. And you were on the trip when the entire Marshall Center team came to Glenn, and I was just a nobody. It's still a nobody, but in the organizational structure, I was kind of one of the back row people, and we spent the whole day talking about how everybody at JSC was trying to take over the world, kind of where we started this conversation.
We're both going to be in trouble now.
And we got to the end, and everybody's like, okay, this was a great meeting, and I was like, what just happened here? We didn't do anything. We just spent the, and I found a common partner in working that with Dan. And I guess I mixed in serious in the first part, but the serious, Dan, I want to thank you for everything you've done for AIAA. You came in at a time where everybody is trying to understand what is the future of organizations like AIAA. You look for partnerships to build. There's concern about membership. What are we going to do with membership? Why do people, and I grew up, my first credit card was an AIAA credit card. I got a junior year in college. I still have the card today. It's not AIAA anymore. We'll talk about why that is later. But I still have that card today. So I knew how much AIAA, I remember opening up the back of the magazine and looking at these incredible conferences that, wow, it'd really be cool to go to that when I was a junior in college. And I've had the fortune of doing that. I've seen the benefit of this. You have brought AIAA to life again, and I'm really grateful for what you've done for AIAA and for everybody that is here and benefits from the programs that AIAA has. So thank you for that. Thank you for an incredible career that you've given to this country and certainly in your time here at AIAA.
Well, thank you, Jim. It's the team makes this happen.
Let's give Dan a round of applause.
Well, thank you. So in the few minutes we have left, what's the one thing you would like for everybody here to walk away from this conversation as they leave Las Vegas and go on about their business and around the country and around the world?
I talked a little bit about that at the end. What I would add to that is talk about the benefits of what the aviation community does for this country. Talk about the difference it makes in the world. Talk about it to your neighbor. Talk about it to your elected representative, if you so choose. But explain the benefits of it. When you're on the plane going home, even though my first security person told me, like, don't talk to people on the plane. You don't want to share what you do, but talk to people about what you do. There's so much excitement about aviation. Talk to the people about what's happening on that aircraft. Talk to the people about what you do. Make it personal. Humanize it for them. When you hear somebody's human story, it's a lot different than a paper or a presentation. It's the human story that matters, and that's how we should be telling our story.
Great. Thank you. So again, thank you for making the special trip.
Appreciate it.
We really appreciate the insights you're bringing forward. So let's thank Jim for the great and all the time.
Thanks, Dan.
So let's see, I'm supposed to give you your challenge.
Oh, that's
coin.
awesome. Thank you.
There you go.
I love these.
Good. So we do them year by year. You can come back next year to get the next one. Okay, so for our audience, for everybody today, be sure to continue this conversation at the morning Forum 360 that follows this. The Executive Chief Technology Officer panel will kick off at 9:30, so please join us for that. And then the final Forum 360 on the role of demonstrators at 1 o'clock, which is going to be an absolutely fantastic opportunity because taking all of the technology and all of the analysis and putting it into flight test for me, is always the fun part. As we look forward to the future, please mark your calendar for next year's AIAA right back here in 2025. We had 3,800 people here this week. Aviation and Ascend combined with over 700 students. And again, I know John did it up front. I want to thank our sponsors. I want to thank the Lumens AV team. I want to thank all of you for attending and being here. And I want to thank particularly the AIAA staff for all the fantastic work they do behind the scenes to make this an event for you and for all of us to learn and to share our knowledge and our expertise. I will have to say this is my last forum in this role, and it's been quite an honor and a privilege to be here with AIAA for the last 6+ years, get to meet a lot of fantastic people that I would like to have known my whole career, JD and others. It's been an honor and a privilege to work with the AIAA team, work with all of you members, all the volunteers. I'll be around causing trouble somewhere. I don't know where. But again, just thank you for all that you do. Thank you to everyone that make this possible. And everyone have a great rest of your day and safe travels home. Thank you.